In the year 2525, if man is still alive, if woman can survive, they may find.
Hello, this video is about gravity. As you know, there's two parts of gravity. There's planetary gravity, like Earth, and there's universal gravity, like as Newton describes. And they are different. Universal gravity can be defined as the gravity that exists throughout the whole universe. Planetary gravity is the attraction of the planet in question, whatever that planet is. As for Earth, Earth is a special planet. It retains life. We have life on Earth. And as you know it, we are trying to explore other planets that have Earth, and we have come up with zero. But to any event, when we talk about gravity, we are not talking about the speed of light. Relativity, written by Albert Einstein in 1905 and in 1915, wrote a theory that says that gravity and the speed of light are the same things, and they're not. Theoretically, gravity is not bound by the speed of light. And proof of that is Edwin Hubbard's discovery that the universe is expanding. And it's expanding at a rate faster than the speed of light. Now, you take the bulk, the three-dimensional sphere of the universe as it is, and calculate Hubble's dimensions, which is 42 miles every 300 million miles a second, and multiply by the dimension, the three-dimensional model of the universe, and you come up with a sum. And that sum tells you how fast something that can travel within that realm. Now, Einstein, what he did, he says, well, speed of light is the fastest we can travel, so gravity must travel at the same rate, and so gravity and the speed of light are the same. And then he put another equation. He says, and since gravity and light are the same, time is the same. So he took all those three ideas and put them and bundled them into one thing and called that relativity. Now, if all that makes sense to you, I'm happy for you, but it doesn't. For one thing, the universe is traveling faster than the speed of light, which means there's no fourth dimension. See, everything Einstein developed relied on the basis of a fourth dimension, the speed of light, the speed of gravity, and time. Now, if any one of those parameters or basics for his formula fail, then the whole thing fails. So when Hubble says, well, Einstein, the universe is expanding faster than the speed of light, relativity took a bulk, it debunked. I don't know whether he spent the rest of his life trying to fix that, but it would have been quite easy if he took Hubble's dimensions and applied them with the speed of light, but that would have changed everything. Particles. How fast can a particle travel? The speed of light. And that's not true anymore. If gravity is traveling faster than the speed of light, then you could push a particle faster than the speed of light. Who says that particles are limited to the speed of light? Relativity does. Who says that time travel exists if you travel faster than the speed of light? Relativity does. But now we have a universe that is expanding faster than the speed of light, and we are not traveling backwards in time. Or are we? What is happening is, because the universe is expanding, relativity allows us to grow, to see things that in a perspective of futuristic ideas. Now when we look at the universe in the beginning as a cosmic egg, that primeval egg, and whether it exploded or it cracked like an egg, and all this dense space rushed it, to change its composition, and caused it to grow and get larger and larger. We have a material universe that is expanding. Now, there's 2 points to this. Is space expanding, or is the universe expanding? Universe, when I mean universe, I mean material universe. The material universe had to reach a point of what's called critical mass. Now, they have measured this critical mass as 10 minus 500 centimeters square, which is quite a lot. Critical mass. CM is critical mass. There had to have been a point to where the cosmic egg reached a critical point to where its growth was stopped. Not only was it stopped, the pressure that was built up caused it to collapse. And when it did, it created all this material form of which everything is made up of. And it eventually exploded. If we go along with the common standard theory, it exploded into smaller pieces. But when you realize this and analyze it doesn't have to be an explosion. We could look at an explosion in slow motion, and even though it's an explosion, you can see what's happening in it. That's what I call a collapse. In other words, the universe is so big, the the critical mass point was so tremendous that what we see in slow motion of an explosion is what has happened to the universe materially. The planets, the stars, the galaxies that were created, the warping of space, the stretching of space, the magnitude it put on space, and all this is mentioned in my next book. I really don't have a name, though. The name of the book was going to be called The Real Live Universe. I don't know, I might stick with that. But whatever the cosmic aid was that created that tension, that flexibility, was a growing organism, or some kind of growing organism. And as you know about growing organisms, they decay over time. It's like if the cosmic aid was a human body, after 70 years or 75 years, it stops working and it decays. The same process works with the universe, whether we know it. The time frame's much longer, but the perimeters are basically the same. So we have a real live universe is what we have. Nothing dies. Einstein's theory on relativity, based in 1915 and 1905, were an accumulation of things that were put to question: time, space, gravity, and he created a theory with that. And he created an imaginary ship that could travel at the speed of light. The only thing is that ship can travel faster than the speed of light now, as we know it, because of expansion. The idea that the universe is expanding changes everything. That means, what it actually means is, if the universe and its gravity has a perimeter of traveling, orbiting, or rotating at the speed of light, and it is traveling faster than the speed of light, and it's measurable much faster than the speed of light, then relativity is wrong. Period. And the reason they use light is because energy is what gives things weight. You take a hollow mass, we'll call it a mass, a piece of plastic, I don't know, okay, a piece of plastic, and you fill it up with water, and that water is energy. Now you take that empty ball and you place it somewhere 3 miles above the atmosphere and put water in it that is energy, and it starts to fall. It falls. It falls towards the surface, and it gains acceleration at a certain point, at a certain velocity, each second. Well, atoms and subatomic particles work the same way. You take them into space and they weigh nothing. They don't weigh nothing. Zero. But you add energy to them and they gain mass. This is why a ship in space can travel at velocities relative to the speed of light, which is very, very fast. Even half of the speed of light. Einstein said we have a flat universe which has a mass of about half the speed of light, which is 93,000 light years across. Billion light years across, excuse me. It has to be billion. See, billion is something that they put in there, when you measure the universe. 13 billion light years, or whatever it is. Now, the universe is not a flat space. It's three-dimensional. So if it's 93,000 light years in diameter, then you multiply it by pi, and you got like a lot. And my equations go further than that, and they give a preferable sum of how large the universe is, and it's expanding. And each second is expanding. And I'm not talking about by length. I'm talking about by bulk. You can look at the expansion is like having a basketball, and you have a pump, that pushes air in it. You push the pin in there, and when you press on the pump, the basketball doesn't get longer or wider; it gets rounder. It's three-dimensional. It gets rounder and on all phases. And this is how you have to measure the universe, as a three-dimensional sphere, like everything else. The moon, the stars, the planets, Jupiter, Neptune, all of them. They're all round, or preferably round. They might have hard surfaces and stuff, but they are preferably round. And this is the basics of my theories, the quantum physics theory, that there's more to do than the speed of light, And until that's changed, you go back to 1943 when Edwin Hubble made that discovery. Science is way ahead of us. So we're talking about 75 years ahead. They say, well, the government's 75 years ahead of us. Of course they are. And they're not going to tell you. And they're building all these spaceships and shit.
In the year 2525, if man is still alive, if woman can survive, they may find.
Universe. And it's got everything in there. Everything that I've mentioned here, it's in that book. Thank you very much.